Wouldn't it be nice to support music instrument practice with the technologies that we create in the music information retrieval field? Let's take a very simple example. Here we have Carla, who is a vocal student, and she likes to practice in her room. Sometimes she's practicing exercises which are given to her by her teacher. She would have a score for these, typically. Other times, she's performing a song from start to finish over a backing track. And sometimes her practice would be very free-form, where she could start from a song, but then she can repeat sections in different orders, depending on what she wants to emphasize. Wouldn't it be nice to support her practice and give her diagnostics? Let's concretize this problem a bit further. So we can always assume that we're going to have the music score, because typically we would want to compare Carla's performance or practice to a reference. So to do that, then we would need to synchronize between her audio, her performance audio, and that reference we're comparing to. And lastly, if she was performing over a backing track, then we need to remove this backing track from the mix so that the feedback is only on her voice. In my research, I will only be tackling the synchronization part. My name is Alia Morsi, and my supervisor is Professor Javier Serra, and my work is titled Audio to Score Alignment for Music Instrument Performance Analysis. Since we're assuming that Carla always has a music score for what she's practicing, then this problem of synchronization is called audio to score alignment. Audio to score alignment has two variants. It can be conducted in a real-time fashion, where you are synchronizing the audio as it is being received, or it can be conducted in an offline fashion, where you assume that you have the full audio file from start to finish, and then you will be synchronizing it with the reference or the music score. First of all, current solutions only work if the audio is almost a perfect match of the score or the reference. We cannot make that assumption for practicing, where we need to be more tolerant to structural variations or mistakes. Also, dynamic time warping, which is ubiquitously used in audio to score alignment solutions, is quite slow. Which means that it might be a good time to consider a paradigm shift in audio to score alignment solutions in general. But of course, data is our biggest bottleneck. There aren't that many datasets available for audio to score alignment, and the ones that are available are few and often not public. Which brings us to the first work we did. So we investigated if we can recycle datasets created for other tasks for audio to score alignment. And in our first experiment, we tried to recycle a beat tracking dataset, which is openly available. Of course, beat tracking annotations are sparser in time than those needed for audio to score alignment, so we used piecewise linear interpolation to approximate what falls between the beats. And of course, this is not perfect, and the rest of our work was analyzing what the pitfalls of this approach are and how it could be improved. Thanks so much for listening. If this was interesting or if you have ideas, I'd love to hear them. Please reach out. Ciao.